Good morning everyone. Today we will see the 8086 interrupts. The main three different sources of 8086 are as follows. First, an external interrupt signal is applied to, say, the NMI pin or INTR pin. NMI means non-maskable interrupt, or an INTR pin. This is particularly called as external signal and known as hardware interruption. Whereas if the instruction occurs like INT, then it is known as software interrupt. And if the last one as some error condition produced by an execution of instruction, such as suppose we are dividing a number by 0. So basically these three are the different sources of 8086 interrupts. On the basis of that sources, we can classify the 80 interrupts as follows: that predefined interrupts and user-defined interrupts. Predefined interrupt, as we have seen, this some specific error condition occurred, then it is known as predefined interrupt. User-defined interrupts can be again classified as hardware interrupt and software interrupts. That is, hardware interrupts mean external signal is applied to NMI or INTR pin, and the software interrupts means the execution of the INT instruction. Now we'll see how the 8086 responds to an interrupt. Suppose this is the main program, and at this particular point interrupt occurs. When an interrupt occurs, the stack pointer is decremented by 2 and the contents of flags will be pushed to the stack. After pushing the contents of flags to the stack, 8086 will clear the IF, that is interrupt flag, as well as the track flag. Then the code segment register contents will be pushed to the stack, followed by the instruction pointer contents to be pushed to the stack. And then after saving the contents of CS and IP, it is ready to fetch the ISR address. Now it will fetch the ISR, it will execute the set of instructions in the ISR. When it finishes with the ISR, it will return back to the main program by use of IRET, that is return from the interrupt. It will pop up the IP, it will pop the CS, it will pop the flags. As we can see here, first we have pushed the flags, then we push the CS, and then we have pushed IP. When we retrieve back to the data from the stack, we should first pop IP, then pop CS, and then last one pop flags. Then we'll go back to the main program. Once you got the older values of IP and CS, you can go back to the main program. Now the next one is how the 8086 can get the address of the interrupt service routine, that is ISR. It goes to the specified memory location to fetch 4 consecutive bytes. Now why it is 4 consecutive bytes? Because we know that the code segment register as well as instruction pointer are of 16 bit. So 2 bytes will be used for CS and 2 bytes can be used for IP. In this case, always higher 2 bytes can be used for CS and always lower 2 bytes can be used as a instruction pointer, that is IP. Now how does the 8086 gets the address of that specified memory location? Now in an 8086 system, the first 1 kilobytes of memory, that is from 0000 to 003 FFH, is set aside as a table for storing the starting addresses of the ISRs. Since 4 bytes are required to store CS and IP values for each ISR, the table can hold the starting addresses for up to 256. Now the starting address of an ISR is oftenly called as interrupt vector or interrupt pointer, and so the table is referred as interrupt vector table or interrupt pointer table. Now we will see the interrupt vector table in detail. Now look at this table. These are the different types of interrupts for 8086, and these are the addresses of CS and IP, means the addresses of the ISR. We'll see this calculation of addresses later on. First we'll concentrate on the types of 8086 interrupts. From type 0 to type 4, these 5 types of interrupts are called as dedicated interrupt. Now why they are called as dedicated interrupt? Because they are having this specific function for every type of interrupt. Say for example, type 0 is known as divide error, type 1 is known as single step error, type 2 non-maskable, type 3 INT, or type 4 is INT overflow. overflow interrupt, whereas type 5 to type 31 are reserved by the processor. Onward, that is type 32 to type 255 are again available by the user. Now we'll see details of these interrupts. Now before going for individual interrupt, we will first understand how the addresses of this ISR can be calculated. 8086 multiplies the type hash, that is by 4, to produce the desired address in the vector table. Say for example type 2. Now type 2, that 2 is multiplied with the 4, and that you will get it as 0008. Now the 0008 and 9 will give the new IP, and A and B, that is the next memory location from 9 is A and B, will give you the new CSN IP. So we will multiply the type number with the 4 and you will get some memory location. That memory location and the next memory location will be used for the IP, that is lower order, and the next two memory locations will be used to get the new CS. Now different types of interrupts, particularly divide error, that is type 0. That this we have discussed before also, that if we are dividing a particular number by 0 and it doesn't fit in the destination, then this type of interrupts can be occurred. The CSN IP for this type of interrupts as 0000 and 002. Single step interrupt, that is type 1 interrupt. The single step interrupt is basically when it always wait for the next instruction. That is when you are when single step interrupt occurs, it will push the flags, it will clear CA, it will clear IF, it will clear TF, and it will execute only one instruction. Again it will stop and wait for the next instruction to run the main program. This is what the single step instruction. Now the new value, the CSN IP for this single step is 04 and 06. NMI is non-maskable interrupt, that is always the highest priority of the interrupt. When the processor receives low to high transition on its NMI, it will automatically generate it. Now IP and CS values are at 08 and 08. Breakpoint interrupt and overflow interrupt. Breakpoint interrupt is software interrupt which is generally executed by the instruction INT3. This is little bit different from the single step interrupt. In single step interrupt we execute only one instructions, whereas in breakpoint interrupt we execute a set of instructions where you are inserting a breakpoint. After a breakpoint procedure, it executes all the instructions up to breakpoint and then it stops the execution. Now for CSN IP values for breakpoint is 0E and 0C. 0E and 0C. Now overflow interrupt. Overflow interrupt is when the result of an arithmetic operation is too large to fit in the destination. That is, say suppose you are storing 9 bits, your result is 9 bit and you have only 8 bit register to store, then overflow interrupt can be generated. So the CSN IP values for this is 012 and 010. Another interrupts are external maskable interrupts, that is type 0 to 255, and software interrupts, that is 0 to 255. Once again, external interrupts, as we have seen earlier, that they are occurred when INTR signal has been generated on the 8086 pins, and the software interrupts when we are executing INT instructions. Again here we have taken the just for an example, just to recall you, that suppose for example type 32 interrupt is there occurs, then the IP can be calculated, ISR addresses can be calculated as follows. For type 32, IP will be put at 4 into type number, that is 32, that is 128 decimal. Hex will be equivalent as 80H, and the CS will be next to memory locations, that is 82H. I hope you all will I hope you have cleared with the calculations of addresses. Thank you.